All right, we're asked to graph an absolute value function where there's a shift in the x direction and a shift in the y direction. You can see here, since x is replaced with x minus 1, we're going to shift 1 to the right. And then at the end, you're adding 2 to all of the values, so that just pushes all the y values up by 2. So this is going to have a simple graph. The vertex will be at x equals 1 and y equals 2. And it's not stretched out or compressed vertically. So when you move from the vertex in either direction, for every unit you move to the right, for every unit you move in the x direction, you'll move 1 unit in the y direction. The slope going to the right of the vertex is 1, and to the left of the vertex, the slope is -1. If you need to adjust your filled in circle to make sure your line goes through the circle, you can just make it a little bigger. All right, now we can combine all of our transformations. In this one, you can see that we're going to have a horizontal shift, a vertical shift, a reflection over the x-axis, and a stretch, a vertical stretch. So first, inside the absolute values, x is replaced with x plus 4. So that will shift the graph to the left 4. And then the -2 at the end of this expression will shift everything down by 2 units. So our vertex will be at -4, -2. Now we're also going to stretch this thing vertically by a factor of 3. So it will be helpful for us to do that before we shift down. What that does when you stretch the graph out vertically by a factor of 3, that means if you start at the vertex and you go over 1 to the right, then instead of going just up 1 to the right, you go up, instead of just going up 1, you go up 3. And the same thing as you move to the left. You go over 1 to the left, you should go up 3 instead of up 1. So you can see that makes the V more narrow. And then we'll reflect that over the x-axis so that it's pointing down. And then the last thing that you want to do in this type of problem is that vertical shift. So I already knew that the vertex should be at -4, -2. But to actually get there and put all these transformations together, I really want to wait until the end to do that vertical shift. If you don't wait until the end, it can be confusing thinking about how the stretching and the reflecting interacts with the shifting up or down. So when you're writing this problem out, I'm taking a lot of time to write it out nicely here. If you're confident, you have some practice with this, and you're confident in your ability to draw this graph, then you don't have to go as slow as I'm going. But if you haven't done it before, then it's really good to write it out nicely in steps like this. And it communicates, if you're taking a test, it communicates to the person who's grading the test that you know exactly what you're doing at each step. It makes it a lot easier to award partial credit as well.